So we're continuing with our model of the light and a mirror with some bouncing going on. So the first thing we want to do, we want to analyze the information that they give us. So the model will be of the form g of x equals, again, this is going to be our standard absolute value equation here with a, the b, the x, the h, and the k. Important thing to recognize is the vertex. Okay, so the vertex, the bottom of our point here, it's going to be at 15, 0, because our origin is right here, 0, 0. The vertex, our pointy part where our function comes to its point, is at 15, 0. So another point we know that exists on the function is right up here. We know this exists, it's part of the function, so it's at 0, 10. So that's what we're going to use when we plug our values into the function. And then the other thing that's good to know is that the opposite wall, this wall over here, is going to be 23.5 feet. We add the 15 and the 8.5, so the opposite wall is 23.5 feet from the first wall. So we want to formulate a plan. So let the base of the first wall be the origin. We have that right here, our origin. So you want to find the value of g of x, where x is 23.5. Okay, we're trying to figure out what is this point over here, where we hit the wall. So that gives the height of the beam on the opposite wall. So to do so, we find the value of the parameters and the transformation of the parent function. So again, like I said, we usually let b be 1. The vertex of g of x will give you the values of the h and the k, our horizontal and our vertical translation. And then we'll use that second point to solve for a. Once we've solved for a, we'll plug in our input of 23.5 to find our height. So let's take a look. So the vertex, again, is at 15, 0. So when we plug that into the standard equation here, we're moving to the right 15, so we subtract it, and we're adding 0 because we're not moving vertically. So then our other point that we knew was on the function is the point 0, 10. So we'll plug that into our function, plug it in there, and solve for a. So our output, our g of x, is 10. Our input, our x value there, is 0. Plug those values in. So we still have 10 over here. 0 minus 15 is negative 15, but the absolute value of that is positive 15. So when we solve for a, we'll divide 10 divided by 15, which reduces to 2 over 3. So that means our general equation that models this function, our a is 2 over 3, absolute value x minus 15. So now we want to evaluate. We want to look at g of 23.5. When you plug in those values, you'll find that your output will be about 17 over 3. Plug that into your calculator, it's about 5.67. So this answer of 5.67, it makes sense because the function is symmetric with respect to the line x equals 15. So the distance from this line to the second wall is a little more than half of the distance from the line to the beam's origin. So since the beam originates at a height of 10, it should hit the second wall at a height a little over 5. Okay. So we're going to do one example from the homework before we send you on your way.